I finally understood why scientists believe there isn't just one universe. Could there be another Earth in another universe? Would there be another version of you on that Earth? I've been seriously pondering these questions for 10 years. And today, I finally understood it all. The universe may indeed not be singular. Instead, there could be multiple universes. Below, I'll combine physics, astronomy, and mathematics to explain what the multiverse really is. Does it exist? If you watch until the end, it will completely reshape your understanding of the universe. As early as 1952, 00:00:42 940 Schrödinger, in a lecture in Berlin, proposed the concept of multiple universes. He stated that the equations he derived seemed to describe multiple distinct histories simultaneously. These histories don't occur at different times, but rather, all histories happen at the same moment. This property is called superposition. It's a concept that's difficult to comprehend. But what's not hard to understand is that the human brain, during its evolution, did not develop the ability to directly understand quantum mechanics or macroscopic cosmic phenomena. Yet, we are still trying to make sense of it. In the multiverse, there may be regions of the universe that are expanding. And we know nothing about these other regions. These universes are essentially independent of each other, never overlapping. Imagine this: you're sailing a ship on the sea, looking toward the horizon. What you see in front of you is your entire universe. And on another horizon in the universe, there's another ship. It has its own horizon. These two ships can't even see each other. Only when the two horizons overlap in some way can you discover each other. But we currently don't know how to achieve this overlap in the real universe. Because there's no physical connection between these universes. To travel from one universe to another, you would need to find some sort of cosmic tunnel. But this process could be extremely dangerous. If the physical laws of that universe differ from those we evolved to depend on, you might instantly dissolve into a puddle of slime. The reason being, if the charge of an electron were to change, all the biochemical reactions in your body would completely break down. The multiverse is a hypothetical description of a collection of multiple universes. These universes encompass everything that exists, all of space, time, matter, energy, information, and the physical laws that describe them. In short, different universes in the multiverse are called parallel universes, alternate universes, or, in popular culture, often referred to as multiple worlds, parallel dimensions, quantum realities, or alternate realities. The physics community has always debated various multiverse theories. Prominent physicists disagree on whether other universes exist beyond our own. Some physicists believe the multiverse isn't a legitimate scientific topic, worrying that excluding the multiverse from experimental verification could undermine public trust in science. This could ultimately harm fundamental physics research. Others argue that the multiverse is a philosophical concept rather than a scientific hypothesis, because it cannot be empirically tested. The ability to falsify a theory through scientific experiments has always been a core component of the scientific method. Nobel Prize winner Steven Weinberg believes that if the multiverse truly exists, efforts to find a rational explanation for the precise values of quark masses and other standard model constants observed in the Big Bang are doomed to fail. Because these values might simply be a random outcome in the specific region of the multiverse we inhabit. In the multiverse, there could be universes whose physical laws never allow matter to coalesce, so stars could never form there. Such a universe would have no life. There might also be another universe where stars can form but cannot produce heavy elements. Such a universe would have stars, and the dazzling night sky we see today. But none of the familiar reality we know. No planets, and no life. Some scientists analyzed data from the Wilkinson Microwave Anisotropy Probe, an unmanned spacecraft that operated from 2001 to 2010, primarily used to measure temperature differences in cosmic microwave background radiation across the sky. They claim to have found evidence that our universe collided with other parallel universes in the distant past. However, with deeper analysis of data from the Wilkinson Microwave Anisotropy Probe and the Planck satellite, scientists found no statistically significant evidence of cosmic collisions. Nor did they find traces of gravitational influences from other universes on ours. More crucially, the multiverse hypothesis currently lacks statistical evidence to support it. Keep in mind that the Planck satellite's resolution is 3 times that of the Wilkinson Microwave Anisotropy Probe in the early 21st century. Regardless of how you view the progress of science, the birth and discovery of quantum mechanics are undeniable facts. Quantum mechanics is a discipline that studies the behavior of microscopic particles. We know that when the scale of study is small enough, humans lose the ability to precisely predict system behavior. We can only describe it statistically. What you can grasp is merely a range of possible attributes. On one hand, we have the vast universe described by Einstein's general relativity. On the other hand, at the moment of the Big Bang, the entire universe was the size of an atom. Thus, we need to combine quantum mechanics, which studies the microscopic world, with general relativity, which studies the macroscopic world. Because at the birth of the universe, the scales applicable to these two physical theories were aligned. Now, when we apply quantum mechanics to the structure of space at the same scale, we find that the space-time structure seems to be gurgling. This phenomenon is actually called quantum foam. When we observe this quantum foam and apply the laws of quantum mechanics to it, we realize that this space-time structure is not limited to a specific region. In fact, in a certain region of quantum foam, an entire universe could be born. And the physical laws of this new universe differ from ours simply because of differences in initial conditions at its birth. Thus, the multiverse is not an imagined concept, but a conclusion derived from applying quantum mechanics to general relativity. Some famous scientists, such as Max Tegmark and Brian Greene, have developed classification schemes for different types of multiverses and universes. Among them, Max Tegmark proposed a 4-level universe classification. Its scope extends beyond the observable universe we are familiar with. Level 1 is an extension of the universe we inhabit, stemming from predictions about cosmic expansion. The core question is whether an infinitely traversable universe exists. If it does, this infinite universe must contain Hubble volumes and can realize all possible initial conditions. Level 2 is universes with different physical constants. In the inflation theory, the multiverse is constantly stretching, and this stretching will continue forever. But certain regions of space stop stretching, forming independent bubbles. These bubbles are embryonic Level 1 multiverses. Level 3 originates from the many worlds interpretation of quantum mechanics. A core feature of quantum mechanics is that certain observational outcomes cannot be absolutely predicted. Instead, there exists a range of possible outcomes. According to the many worlds interpretation, each possible outcome has a different probability of occurring, and each possible outcome corresponds to a different universe. Level 4 is an ultimate ensemble, centered on Tegmark's ultimate mathematical universe hypothesis. This level of theory posits that all universes are equally real and can be described using different mathematical structures. Tegmark points out that abstract mathematics has immense universality. Any theory of everything that can be described with purely formal language and definitions, even without ambiguous human language, is essentially a mathematical structure. He believes that this means any conceivable parallel universe theory can find a corresponding description in the Level 4 classification. And Level 4 encompasses the collection of all other levels of universes. Thus, this level is the endpoint of the multiverse classification. There cannot be a level V. American theoretical physicist Brian Greene proposed a classification of 9 types of multiverses. This content will be explored in my future videos. Don't forget to subscribe.